Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. Today we will learn about the intersection of two events or joint events. So the intersection of two events A and B is another third event A intersection B, which include all those experimental outcomes of the event A and of the event B which are common in event A and B. So A intersection B is another event, a third event, which carry those experimental outcomes which are common in the given event A and B. Suppose, for example, we have the two events, event A and event B, and the intersection of A and B is another third event A intersection B, and this third event A intersection B will carry all those experimental outcomes of the event A and of the event B which are common in both A and B. Let me clarify by putting this example. For example, this is the event A which carry two outcomes, SS and FF. This is one event A, and suppose this is another event B, which event B carry three experimental outcomes, SS, SF and FS. This is example. Suppose this is event A which carry the two experimental outcome SS and FF. This is the second event B which carry three experimental outcome, SS, SF and FS. And now this is the third event, intersection event which is the intersection of two events A intersection B. So A intersection B is a third event which include all those experimental outcomes which are common, mushtarak, in the event A and in event B. So in here, this is event A which carry two outcomes, and this is event B which carry three outcomes. In these two, A and B, this first outcome, SS and SS, this is common in both events A and B. So intersection event is another event which include those outcomes of the events A and B which are common, and the intersection of A and B is A intersection B, which is SS. So this is the mathematical notation for the joint events or for the intersection of two events. A intersection B is SS, because we define that A intersection B is another event which include those outcomes which are common in event A and in event B. So SS, this is first experimental outcome, and in the B, event B, this is first experimental outcome, both are common. So that is the intersection event of the two events A and B. Maira dobara dar zubani dari+eng intersection of two events या joint events, यानी intersection of two events कुदाम event में बाशा हो. मसलन अगर मां दो इवेंट्स दारेम, यक इवेंट ए अस और दोम इवेंट बी अस, आले ए इंटरसेक्शन बी यक दिगा इवेंट जोड़ मेशा, यक सेम इवेंट जोड़ मेशा, और ये सेम इवेंट ए इंटरसेक्शन बी बहु आउटकम मुश्तमिल में बाशा क्यों दर इवेंट ए और दर इवेंट बी मुश्तरक बाशा. मां दोबारा मेगम के A intersection B यक सेम इवेंट अस, और ये A intersection B वो एक्सपेरिमेंटल आउटकम्स दारा क्यों दर इवेंट A और दर इवेंट B मुश्तरक बाशा. मसलन ये इवेंट A अस, ये दो आउटकम दारा SS FF, ये इवेंट B अस, ये हम दो से आउटकम दारा SS SF and FS. आले A intersection B, A तकातो B, ये एक सेम इवेंट जोड़ में शा और ये सेम इवेंट ए इंटरसेक्शन बी मुश्तमिल बवू आउटकम में बाशा कि वो दर इवेंट ए और दर इवेंट बी मुश्तरक अश हो इन जमा ए इंटरसेक्शन बी नविश्ता करें आले ए इंटरसेक्शन बी ए तकातो बी वो इवेंटस कि वो मुश्तमिल बवू आउटकम में बाशा कि दर ए और बी मुश्तरकस या कामनस वो दर ए और बी मुश्तरक एक्सपेरिमेंटल आउटकम कियास वो एस 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 दर बी हम एस एस करार दारा और दर एस एस दर ए हम एस एस करार दारा ये मुश्तरकस बई वजह ए इंटरसेक्शन बी इवेंट कुदाम आउटकम दारा एस एस वो के दर ए और बी मुश्तरकस Marginal event when we estimate the probability of every event separately. The individual event probability is called marginal probability and we are calculating using relative frequency method. Let me again repeat. Marginal event or probability of marginal event. So marginal event, every separate event is called marginal event. Marginal event means every individual event. Every separate event is called marginal event. Mutually exclusive events. Mutually exclusive events. When the experimental outcomes of an experiment are equally likely to occur. When the experimental outcomes of an experiment carry equal chances of occurrence. So if one experimental outcome occur and the other cannot occur, so these events are called mutually exclusive event. When at a time only one experimental outcome or only one event of an experiment can occur and the other outcomes or events cannot occur at a time. So these events or these experimental outcomes are called mutually exclusive events. For example, toss a coin. This is one experiment and toss a coin carry two outcomes, head or tail. Now if we toss a coin and there is a head on the up face of the coin, so tail cannot be occur. But if we toss a coin and there is a tail on the up face of the coin, then head cannot be occur. So mutually exclusive events are those events which exclude one event in which one event exclude the other. When both events at a time cannot occur. So these events are called mutually exclusive events. And here toss a coin carry two outcomes, head and tail, but both cannot occur at a time. If there is a head, tail cannot occur. If there is a tail, head cannot occur. So head and tail both are mutually exclusive events because head exclude tail from the occurrence and tail exclude head from the occurrence. So mutually exclusive events, such events in which at a time one event occur and other cannot occur. And we put example. Let me read this theory. Those events of an experiment where if one outcome occur and the other outcome cannot occur is mutually exclusive events. The outcomes exclude each other. For example, toss a coin. So sample space. When we toss a coin, the two outcomes are possible. There will be head or there will be tail on the up face of the coin. But both head and tail cannot occur at a time. Suppose this is event A. There is a head. So when there is a head appear on the up face of the coin, tail cannot appear. So head exclude tail. Both events are mutually exclusive. One event reject the other. And if there is event B occur tail, so head cannot occur because there is a tail on the up face of the coin and tail exclude head. So these head and tail are the mutually exclusive events where A and B are mutually exclusive events because if this is head, it cannot be tail and at a time. If there is a head it cannot be tell at a time. ما ایره دوباره در زبان دری میگم که marginal event چیست. marginal event هر individual outcome را میگه. هر جدا علیحده separate event را marginal event میگه. mutually exclusive events کدام events را میگه. او experimental outcomes یک experiment که یک outcome دیگره را exclude میکنه، خارج میکنه، reject میکنه. با یک وقت اگر یک outcome experiment واقع میشه خود دیگه outcome و experiment امکان نداره که واقع شود. اینطور events یا outcomes را mutually exclusive events یا outcomes میگه. ما مثال دادیم که مثلا اگر ما toss میکنیم خود toss دو outcomes داره، یک head دوم tail. اگر head می آیا سر سکا بالا on the up face of the coin اگر head می آیا خود tail امکان نداره که بیایا. خود head چی کد؟ tail را exclude کد. اگر toss کدین او tail برآمد خود tail آمد اور head امکان نداره که بیایا. tail head را exclude کد. یہ mutually exclusive events است. اگر یک ایونت واقع میشه خود دیگه ایونت ها امکان نداره که واقع شوه. ای ایونتس را mutually exclusive events میگه. ما مثال toss coin دادیم. اگر head می برای خود tail امکان نداره که برای. اگر tail می برای خود head امکان نداره. ای outcome یہ events کی است ایرا mutually exclusive events میگه. Probability laws. In this section we will learn about the different statistical measures that we will use to determine the probability of a particular event or determine the probabilities of the different events of an experiment. So we are learning about the different laws. We will learn about the addition law. Addition law is used to assign probability to the specific event out of the more than one events. And similarly we will use multiplication law to assign probability to the joint events or to the intersection of two events. So in this section we will discuss the different laws of probability, and these laws we use to assign probability of the single unit or more than one units. So we are starting from the very first law, that is addition law. Addition law is used to determine the probability of the union of two events. As well as addition law we will use to determine the probability of the specific event out of the given 2, 3 or 4 events. For example, we have the two events A and B. So how we can define the probability of the union of A and B, for example A union B. So addition law help us to determine the probability of a specific event, event A or event B, or determine the probability of both A union B. So simply addition law is used to determine the probability of a specific event or determine the probability of the union of two events. And this is the mathematical notation. Mathematical notation, probability of A union B. A U B, this is the standard form of the A union B. So probability of A union B is equal to probability of A plus probability of B minus probability of the joint events or probability of the intersection of A and B. So this is the mathematical notation to determine the probability of the A union B, or to determine the probability of a specific particular event, A or B or of both. So ما ایره دوباره در زبان دری میگم که ادیشن لا یک statistical tool است که با کمک یک طول ما میتونیم که probability یک مشخص ایونت را کلکولیت کنیم، اندازه کنیم، یا probability یونین دو ایونتس را اندازه کنیم یا کلکولیت کنیم. مثلا probability of A union B باید کلکولیت کنیم، یا probability of A کلکولیت کنیم، یا probability of B کلکولیت کنیم. خب با کمک ادیشن لا probability یک مشخص ایونت هم پیدا میشه، استیمیت میشه، کلکولیت میشه، او probability union of two events A and B هم کلکولیت میشه. Addition law is used to measure the probability of a specific event out of the given events. Let A and B are two events, then addition law is used to measure the probability of event A or of event B or of both events A and B that we call A intersection B. Means ये बई माना कि addition law की आज बकुमा की ये probability एक मुशख़्ख़स event हम calculate मेशा, probability union हर दो events हम calculate मेशा. For example, toss a coin. Suppose this is one example. We toss a coin. And when we toss a coin, the question is this: determine the probability of A union B. So, determine the probability of A union B. P is missing in here. The question is this: determine the probability of A union B when we toss a coin. So, when we toss a coin, the sample space, that is S, is equal to head, tail. Sample space represent the total possible outcomes of tossing a coin. So toss a coin is experiment and it carry two outcomes, head and tail, and the total number of outcome n represent number of outcome, that is 2. So this is event A, which represent the outcome head, and this is event B, which represent the outcome tail. So first I am assigning probabilities to event A and event B using classical approach. We study this. Probability of A is equal to 1 over n. N is 2, so 1 over 2 is equal to 0.50. Probability of event B tail, that is probability of B 1 over 2 is equal to 0.50. So we calculate the probability of event A and we calculate the probability of event B using classical approach. Now, these two events A and B are mutually exclusive events. If event A occur means head occur, event B means tail cannot occur. But if tail occur, so head cannot occur. A represent event head and B represent tail. So if head is occurring, tail cannot be occur. If tail is occurring, head cannot be occur. So it's mean the intersection, the common outcomes in A and B, that is 0. Nothing is common in event A and in event B. This is event A head and this is event B tail. No any experimental outcome is common in these two events. That is why the probability of A intersection B, that is 0. Both events A and B are mutually exclusive events, cannot occur at a time. So the intersection of the two events A intersection B, that is 0, and the chance of the occurrence of common outcomes in event A and B, that is 0, no chance. So probability of A intersection B, that is 0. Now we have the probability of A, we have the probability of B, and we have the probability of the intersection of two events A intersection B is equal to 0. Let me repeat again, A intersection B is another event which include all those outcomes which are common in A and B. So is there any common in event A? In event A, outcome is head. In event B, outcome is tail. Nothing is common. So that is why the intersection A intersection B, that is 0, and probability of A intersection B, that is also 0. Yani no chance that there will be any experimental outcome common in event A and B. So that is 0 chance. Now we will put the values in formula. We have probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So probability of A union B is equal to 0.50 the probability of A plus 0.50 the probability of B and minus 0 the probability of the intersection of two events A intersection B. So 0.5 plus 0.5 is equal to 1. The probability of A union B, that is 1. Now ma ila dobara dari wazih mein kunum example ra. For example, toss a coin. Waqti ki ma toss a coin mein kunim ye do outcomes mein ta yak head aur dom tail. Ye sample spatial head tail. Ma outcome awal head ra yak ism A dadim ki ye event A as ki outcome ra nishan mein ta head ra ye event B as ki wo outcome tail ra nishan mein ta. Ale probability of event A ye ba classical approach ma calculate mein kunim chira ke head or tail kya su equally likely to occur, equal chance dara ki occur sho. By wajah probability of head or probability of tail, probability of A or probability of B ma the classical approach calculate kadame tanim. Probability of A is equal to 1 divided by 2. This is formula is 1 over n, and why I am putting here n is equal to 2, because the experimental outcomes total experimental outcomes are 2. So that is why 1 over 2 is equal to 0.50. The probability of B again is equal to 1 over 2, 0.50. And ye inja probability of A intersection B 0 A by mana ke dar event A or dar event B kodam mushtarak kodam common experimental outcome nes by wajah chance mushtarak ya chance of common outcome wo sifar as alima probability of A, probability of B or probability of A intersection B ra dar ye formula probability of A union B wazam mein kunim where 50% plus 50% minus 0 and probability of A union B is equal to 1. Yani ye ma A union B probability A union B kashidin. Ho probability A union B malum shud. Agar inja probability of B malumas, probability of A intersection B malumas, or probability of A union B malumas. Ho statistician metana ki probability of A rahum मालूम कुना अगर A union B probability of A intersection B मालूम है वो मीता ना कि probability of B रहम मालूम कुना मा इरा दोबारा मेगम के addition ला किया ये addition ला वही माना कि probability union of two events by चितोर अंदाजा शवा estimate शवा को addition ला किया सो probability A union B रा estimate में कुना calculate में कुना अब ये formulas probability of A union B probability of A plus probability of B minus probability of A intersection B अब ये इंजा as example वाज़ह शो